Good day everyone, this is my part 2 of the 6th chapter of the thermodynamics, which is the gas and vapor power cycle. So here is my sample problem. The compression ratio by air standard Otto cycle is 10. The beginning of the compression stroke, the pressure is 0.1 megapascal and the temperature is 15 degrees Celsius. So the heat transfer to air per cycle is 1800 kilojoules per kilogram of air. So determine the pressure and the temperature of each process of the Otto cycle. And then the thermal efficiency. Next is the main effective pressure. To solve this problem, we have to solve first the B1. So we have values here. B1 is equals to 0.287 times 288.2 over 100. So we have our B1 here, which is 0.827 cubic meter per kilogram. And then we have T2 is equals to T1 times R raised to K minus 1. So substituting our givens, we have 288.2 for our T1 times 10 raised to 0.4, and our temperature here would equals 123.9 Kelvin. Next, for our P2, we have the formula P1 times R raised to K. So we have 0.1 times 10 raised to 1.4. Value for P2, which is equals to 2.512 megapascal. And then we need to solve for B2. So we have here B2 is equals to 0.827 over 10 is equal to 0.0827 cubic meter per kilogram. And then to solve for our 2Q3 here, we have the formula Cv is equals to T3 minus T2, and it is equals to 1800 kilojoules per kilogram. So this is our heat transfer per cycle of air. And then to solve for our T3, we have the formula T3 is equals to T2 plus 2Q3 divided by Cv times T3 minus T2. So substituting our givens here, we have 1800 kilojoules per kilogram over 0.717. We have the value of 2510 Kelvin. And then we have the value for T3 here, which is 3234 Kelvin. And then to solve for P3, we have the formula T3 over T2 is equals to P3 over P2. So plugging in our givens, we have 3234 Kelvin over 723.9 Kelvin is equals to 4.467. Value for P3, which is 11.222 megapascal. And to solve for our T4, we have the formula T3 over T4 is equals to B4 over B3 raised to K minus 1. And it is equal to 10 raised to 0.4 equals to 2.5119. And our value for T4 is equals to 1287.5 Kelvin. Then for solving our P4, we have the formula P3 over P4 is equals to B4 over B3 raised to K. And it is equal to 10 raised to 1.4 and equal to 25.12. So we have the value for P4, which is equals to 0.4467 megapascal. Next, solve for our thermal efficiency, we have the formula 1 minus 1 over RK R raised to K minus 1. So plugging in our givens, we have 1 minus 1 over 10 raised to 0.4 is equals to 0.602 times 100, so we have 60.2%. And then to solve for our for Q1, we have the formula CB is equals to T1 minus T4. So we have 0.717 times 288.2 minus 1287.5, and it is equal to negative 716.5 kilojoules per kilogram. So our thermal efficiency would equals to 1 minus 716.5 over 1800 kilojoules per kilogram. So cancel out our kilojoules per kilogram here. So we have 0.602 times 100, so it would be 60.2%. So to solve for our W net, here we have 1800 kilojoules per kilogram minus 716.5 kilojoules per kilogram, and it is equal to 1803.5 kilojoules per kilogram.
Lastly, for our
mean effective pressure, we have V1 minus V2 times mean effective pressure. So mean effective pressure is equals 1083.5 over 827 minus 0.0827 is equals to
1456